Alrighty, maybe we can go ahead and get started. Cool. Hey, everybody. Excited to chat today a little bit about detections as code and how we think about handling detections at scale, and how we think about the importance of security data lakes for the future. But please feel free to throw questions in the chat, and then Alex here, who's on the founding team and head of ops at Scanner, will make sure to interrupt me and get those questions answered. But yeah, we can go ahead and dive right in. Cool. Uh, the most interesting thing that we've run into in our own efforts to try to make sense of logs is to make it much easier to search through a huge amount of log data. Log data is just growing in volume like crazy, especially cloud operational logs. And at Scanner, our vision is we want to make it really easy to search through years of logs. Like it should be a thing of the past to only have like a few days or like a few weeks of log retention. And it shouldn't be so expensive to manage logs at scale. And we'll talk about that a little bit just to kind of give an overview of Scanner and why it exists, and then we'll dive into detections. The reason why our users and our security teams are using Scanner is because it really makes it easy to run a data lake and to query it at a very high speed, and it makes it extremely easy to use. So by giving people access to a data lake, which is just like a place where you can store lots of messy data. Usually it's in cloud object storage, and making it possible to store years of that data and get access to it and get rapid query power on that. It gives teams a lot more power for detection and response and threat hunting. You can do a lot with this data. And the way that we make data lakes fast, but also very easy to use is we really think that there are tools on data lakes, especially that are related to logs, need to be schemaless. And we really think that in the future, instead of shipping your logs to a vendor, the logs that you have in scale should really be maintained in your own S3 buckets. And so I'll talk about like some of the pain points that people run into, that we ran into, and why we built Scanner. We really think that traditional logging architectures are just totally wrong for modern log volume. What you need to do is you need to run like a big search cluster, and as a result of storing the logs in expensive hardware, like on expensive hard drives, is that data retention often becomes extremely short. So it's not unusual to have log retention of maybe 7 days or something like that, or like sometimes even 3 days. But the problem with this is it's extremely important in security, is that it's very challenging to investigate logs if you have such short retention for threat exposure. So you might have some kind of threat that the world becomes aware of, like maybe, for example, Azure had a vulnerability for a couple of years and then told everybody like happy birthday, like we've had this vulnerability for a long time. If you don't have an ability to go through your historical data quickly and investigate whether you've been exposed to that threat, it can be a huge problem. And so we really believe that data lakes are the future of log management in security. Data lakes that are based on object storage, where you can store a huge amount of data for a very long time, just way more cheaply than storing it in a really expensive, hard to maintain search cluster like Elastic or Splunk. But the interesting thing is that all current data lake tools use SQL. So they're all very tabular. They're all designed for business transactional data, but logs are messy. There are plenty of security logs that are well structured, but there are also plenty of security logs that are crazy nested JSON or plain text. And it can be a challenge to transform these logs and to normalize them into a schema and onboard more log sources. And it can be really hard to search through those log sources. If you need to know the schema, it can be slow. There are lots of problems with SQL tools which are kind of the only tools that you can operate on data lakes at the moment. And so what we really believe in is at Scanner, we want to make data lakes way easier to use. The idea is to provide schemaless search on top of this data in your data lake. So you just point Scanner at your S3 buckets, and your S3 buckets might be full of just raw log data, raw JSON, raw Parquet, or plain text or CSV files, and Scanner will make that easily searchable. That data gets transformed into index files, which are also stored in your S3 buckets. So all of the data remains with you in your own buckets. And by making these index files, it makes it very easy to do super fast searches across months of logs. So other kinds of SQL tools, like if you're using Athena or something similar, it might take you hours to run queries if you need to go through and find indicators of compromise in months of logs. But in Scanner, Scanner's really designed for indicator of compromise search and needle and haystack searching. It will take seconds to do that same query instead of hours. And in addition to this, instead of requiring teams who are using data lakes to run these slow scheduled searches, which can go and scan through lots of data continuous all the time, which can be expensive, Scanner is designed for continuous threat monitoring using a novel roll-up tree approach. So you get these out-of-the-box detection rules that we have, but also you can write your own. That tends to be the thing that most of our users do, is writing their own custom rules. But at scale, because you can handle way more log volume in S3 and handle way more log volume in Scanner as a result than you can in a traditional SIM, you get a lot of you get a lot more coverage of the log sources you want, and you can monitor for threats that you couldn't before. But the thing is, with the data flowing into S3, there's a ton of data flowing in, so we have to be really smart about the way that we do this continuous threat monitoring, these continuous detection rules. So I'm going to dive into how that works, and then I'm going to dive into and walk through how to use it. So a couple of customers that are using Scanner for threat hunting and for detections. It's been really fun to work with them and get their feedback. I don't know if anyone here knows folks on these teams, but we've been excited about helping people get visibility into years of logs instead of the past 7 days. Yeah, it'd be fun to chat more and see if we know folks in common and how we can help each other develop really good security postures on all of this data. Anyways, cool. Let's dive into detections as code here and how we think about doing detections in Scanner. The idea is that we want Scanner detections to be really easy to develop, but also we want it to be very simple to collaborate with members of the team and make the detections more and more sophisticated over time and testable, and allow teams to have really strong change management. And so we'll dive into a bunch of details on how this works. But the idea is that Scanner has this detection rule engine that will analyze new log files as they flow into the system rapidly. So as you add new log files to your S3 buckets, there's this automated log analysis that happens on the fly. And I'll talk a little bit about the architecture for how that works, but this allows you to get these real-time alerts. So instead of running scheduled queries to go and query your data once an hour or once a day or something like that, the way that Scanner rolls up aggregations into a cache means that you can run your detection rules even over a large time window. You can have that rolling time window running every minute, and so you can get faster alerts that way that come in. Instead of once an hour, you can get notified within 1 minute. There are a couple hundred detection rules that we have out of the box, 240 detection rules for 12 common log sources that our customers care about. The particular focusing on cloud operational logs. So these are like cloud audit logs, but also web application firewall logs or SaaS tool logs like GitHub logs or Slack logs or Google Workspace and so on. So there are these out-of-the-box detections that you can use as well. People are totally free to share their own Scanner detection rules on GitHub, but all of our out-of-the-box detection rules are there publicly on GitHub, and can dive into the detection engine too. But I did notice, I think I got a little notification that someone raised their hand. I don't know, Alex, did you see that?
I did see it pop up, but maybe you answered the person's question. Looks like they took their hand down.
Oh, okay, cool. Happy to answer any questions if someone wants to jump in there. Sorry I missed it. Anyways, feel free to stop whenever. I'll talk a little bit about how the detection engine works. So as logs flow into Scanner, as new log files end up in the user's S3 buckets, then the Scanner's indexers will look at these raw log files and start to create Scanner index files and save those in S3. But all of those logs run through what we call this detection engine state machine. And this state machine actually executes all of your detection rules simultaneously. And as a result, you only make one pass over all of the log data. You're not doing like these scheduled searches to go and explore data continuously and where every detection rule query makes its own pass. All of the logs that flow through, because they'll be flowing through into your S3 buckets at really high scale, like terabytes or 10 plus terabytes a day. It's challenging and not super trivial and not super efficient to go and run lots and lots of parallel queries that all make a pass over the data. The state machine runs all of the detection rule queries simultaneously. And so then what happens is the aggregation values from those queries. So if you have like a simple query, those are really easy, but you might have a more sophisticated query, which is like, I want to compute some stats over a large rolling time window, and only if those stats if those computed values exceed some threshold, then I want to be notified. Like, how can you support that if you're just running through the logs in one pass through the state machine? And the way that we do that is the aggregation values from your queries are saved in this time bucketed rollup tree cache that's in S3. And so this cache is really small because it's just storing these saved values. And of course, like you might need to tune a query or something to make sure that, if you're accidentally storing like every single log message cached, then it'll truncate it. But anyways, if you're writing aggregation queries and detection rule queries that are suitable, and you're not trying to cache like giant messages in there, then on average, the detection rule cache tends to be less than 1% of the original size of the logs. So it's this cache data structure which contains these aggregation values, and then that cache data structure is checked with this rolling sliding sliding window. So up to once per minute, your detection rules can run. You can decide how frequently you want a detection rule to run, but once per minute is totally fine. That's the fastest you can go. And what it will do is the sliding window for that detection is going to go and query this rollup tree. And you can see the sliding window covers like a wide time range, but because there are bigger time ranges with aggregation values that are cached as one single value, you can very, very rapidly roll these values up together into a single aggregation value. So that's the point of this, is to make it really fast to run this sliding window and then determine if a detection rule should be triggered. So this is a lot of detail in how it works, but we really think that in order to handle the massive amounts of log volume that people have, that the naive way of just running scheduled queries that each need to make a pass over the data doesn't work at scale. And so there needs to be a new approach that is far more efficient. And I'll get into detail now about how this works with an actual detection rule. So a detection rule is defined as a scanner query, and you can either write these in the UI, or you can write these as YAML files in a GitHub repository that you share with your team. I'll dive into and show everyone how that works in a second. But this is just kind of demonstrating how a given detection rule might work. So it might be the case that you have a query which is going to look for get object requests on S3. This is like basically downloading data from S3 buckets, and it's doing a little bit of transformation to it, and then it's aggregating and computing a sum of the total amount of data that's been transferred out, and then it's counting the unique number of S3 keys that have been downloaded, and it's grouping it by the source IP address, like basically the users and the clients who are downloading this and gathering by their IP addresses. So what happens here is as the data flows in to the scanner detection rule engine, is it's running the entire query up until the first aggregation, which is the stats part of the query. And that aggregation value is stored and is cached in this rollup tree. And so then later, once per minute or however long you decide to set in your detection rule, it's going to just run the final part, which is like the condition after the aggregation has been computed. And it will, on that sliding window, go and check, like, okay, over a 15-minute time period or whatever you set in your detection rule, is the number of unique keys greater than 10,000, and it will query this rollup tree to go and gather that data. And if that has been triggered and that condition is true, then it's going to fire off alerts to different destinations, whatever you've decided to configure in your detection rule system. So you can send alerts to destinations like Slack or to SOAR tools like Tines or Torque are really common for our users, or to your own custom webhooks, which might point it to Jira or to Linear or to other issue trackers. So basically, with a scanner detection rule, once the condition is met, then the data, the query results from that detection rule are going to be shipped off to different destinations, whatever you've decided to configure. So just to chat about some of the benefits before getting into the demo, the cost really comes down if you do things this way. So instead of feeding everything into a really big search cluster like Elastic or Splunk or something, what you're doing is you're just streaming data through a state machine to do these detections, and the cost comes way down, 5 to 10x less compared to traditional SIMs. It's also less than it can be less expensive than other tools that use data lakes because they might rely on something like Snowflake to run these scheduled queries or something like that, or run lots of Lambda functions continuously on all of the files that come in. But anyways, we really believe in making it really efficient to handle all of this data at scale. So because it makes a single pass over the data, it's highly efficient. It can scale much more easily to terabytes or tens of terabytes of logs per day. And the detection rules run simultaneously, so you can actually run them very frequently because checking this rollup tree data structure is really fast. You don't have to schedule queries to run like once a day or once an hour. Your queries, even with large look-back windows, can run very frequently. Cool. Okay, so I'm going to walk through a couple of different flows in the app. So I'm going to kind of show Scanner how you might start to develop your own detection rule, what the detection system looks like, and then how you would use the Scanner CLI tool on your own laptop to start to write detections and test them, how the workflow works through GitHub. Gives your team the ability to do code review and good change management. How the CI/CD flow works. So as new commits are pushed, all the tests run, and if all the tests pass, then it gets fed into Scanner. So let's go ahead and bring up the app here and start to play with it a little bit. This is the Scanner Playground environment. It has CloudTrail logs, and you can follow along in our documentation. We have a guide that shows how investigations might work and the kinds of detections you might want to do. But Scanner, the first pillar of Scanner is search, just providing teams the ability to do lots of search at massive scale. And the second pillar is detections. But just to kind of give you an idea of how we think about about how logs should work inside of S3 and inside of data lakes is these log events are very flexibly structured. These are JSON logs, these are CloudTrail audit logs that have deeply nested structure here. And you don't need to, every time you make a new log source, you don't need to map them perfectly to a SQL schema or anything. It can really be any structure, and all of the fields are searchable. So no matter what it is. So like even if I have like this really deep field here, I can add this to the search and like start to execute queries like very rapidly across the data here in Scanner. So anyways, the Scanner is really strong for doing this schemaless search over the data. But let's dive into detections here and just give a quick overview of what that looks like. These detections are the out-of-the-box detections for CloudTrail logs. You can see here that you can supply tags to detections. These are MITRE tactics and MITRE techniques. So if I want to dive in and see like what is everything related to defense evasion, I can click on a tag and start to filter down. Or you can jump into this sidebar here and search for different tags that you're interested in and filter. Like maybe I want to see the medium and high severity detections. You kind of play around with this and find what you're looking for. A detection rule, as I was sort of talking about in the slides, I'll just like pop open any of these. A detection rule consists of a name, a description, and then you can supply severity and tags. But the heart of it is the query. So this particular query it's looking for, it looks like administrator access being attached to a group, which can be very spooky. Hopefully you're not doing this all the time. If you are, you could add exceptions to your detection rule in the query here, and we'll walk through doing that in a second. But you can see that the time range, you can specify the rolling window you want to look at and how frequently you want to check. And so in this particular case, we want to check immediately. So this is like, are there any hits at all for this particular kind of activity? And then that you can decide where you want your events to be sent to. So it can be all of the events get sent to something we call the detections index. So you can open up the detections index and search through your detection, your trigger detection alerts, the same way that you can search through logs. And you can also send them off to Slack or to other tools with, like this is a Torque webhook, for example, to your SOAR tool. Anyway, so this is what a detection rule looks like. And so it might be kind of fun. The first thing that we can do is start to play with the logs a little bit and come up with our own detection rule. We'll use the UI for that. And then we'll dive in and show how the detections as code with YAML and GitHub works. Oh yeah, I see Alex raise your hand. How's it going?
Yeah, question just sent in. For detections as code, can I use Python or is it just queries?
Yes, it's just queries. So that's a great question. Yeah, I think there are other tools where the code, and I actually will just pull this up here real quick on what a detection rule looks like in code. Python can be nice, but one of the powerful things about using queries is that you can do more complex aggregations over time and not just do filtering. So one of the things that you might run into if you're just using Python as a detection rule would be you can look at maybe one log event at a time or small batches of them, but to look for a pattern or compute some statistical values over a large time range, then you might have to fall back from Python to writing like a SQL query or something like that, which might be slow to run or expensive to run. But yes, in Scanner, the Scanner queries allow you to do filtering, just like detect if there is ever a log event that meets some criteria, then trigger immediately. Or you can do things like compute stats over rolling time windows and do more sophisticated kinds of things. And yet it'll run really efficiently due to that roll-up tree cache that I was talking about. So, but yeah, great question. It is they are scanner queries is how scanners detections as code works. So the code is YAML, I would say, and it's there is also, I think, one thing that's kind of interesting is I'll just pop up here. Speaking of Python, is we do have a Python SDK. This is a Jupyter notebook that uses the Python SDK, and what this does, and I could probably just run it here. This is sort of like responses code. You can use the scanner SDK to go and execute scanner queries and then pull in data and visualize them. Maybe your team has Jupyter notebooks or other kinds of run books that they can use to go and respond to things. So this is like this is using the scanner SDK to go and execute some queries, gather the results, and visualize. These are assume role graphs in AWS. So it's like what roles are assuming which ones. Maybe if you saw like a long chain of assume roles, it might be kind of scary, as it might be someone trying to evade defenses. So anyways, you can use I guess where Scanner interacts with Python is we provide a Python SDK that users, a bunch of our users use in Jupyter notebooks, or they'll use it in like their own custom webhook to go and execute queries in Scanner to enrich alerts. Anyways, yeah, that's a long answer to that question. But yeah, high level detections, Scanner detections are queries, but there is like a Python SDK that Scanner provides that people use for response or threat hunting. Yeah, which can be helpful. Okay, cool. Oh yeah, Alex.
Another question just came in. Can we have our data in Parquet format sitting on our S3 and detections run on it? Or does the data have to pass through some pipeline? Like, does it need to be transformed and stored in another S3 bucket for indexing needs?
Oh, it's a good question. So I guess I can even open up how Scanner works real quick over here, just a little bit of a visualization. Yes, if you have Parquet files, then Scanner can analyze them, but Scanner will create index files in this other bucket. The idea is that the Scanner index files are the only files that Scanner can search through and can analyze. And the Scanner index files are designed to be schemaless. So if you have some of your data is JSON, some of your data is Parquet, some of your data is CSV or CSV files, Scanner will create these extra index files here. So I guess you don't have to do anything though. You don't have to transform your logs into a different format or put them anywhere else. You can just store those Parquet files in your S3 buckets as long as Scanner is you set up an IAM role in your environment to allow Scanner to read that. Then Scanner can create index files for you and start to provide detections on it. So yeah, you don't have to do anything like pull those Parquet files out, run it through your own Logstash pipeline or something. You can just say, I have my Parquet data here, and Scanner will read that and then generate index files and run detections on it. Hopefully that answers your question. Cool. Anything else, Alex? Any other questions?
Not yet.
All right, cool. Awesome. So yeah, let's dig into a couple of the a rule a little bit further, and I think what might be interesting is to the next thing we can do is to pop open what the detections look like. So you can search through detections, and detection alerts are just the same thing as logs. You can search through them, you can query them, which can be very powerful. You can even write detection rules on top of the detections index to do like meta detections and see if there are entities that are showing up a lot in your in various alerts. You might raise like a a cross-source detection might raise a critical alert if it detects that a particular user or IP address or something seems to appear in many different detection rules or detection alerts. So here I can see that this particular detection is one of our out-of-the-box detections that is going off and is showing that this particular user is updating a Lambda function in a strange way. It could be like a malicious Lambda layer. So what you can do is you can start to piece these together either with a query, like running a query here, or using the query builder. You can start to dive in and do more of an investigation. You could say like here, let's look for yeah, we could say here like where the name of the alert is this malicious Lambda layer. And then we can do things like group by count and say, here's the result row, and let's get the result table. Whoops, results table dot rows 0, and see what users are showing up in these alerts. And it seems like this particular user is showing up a lot. So this is like a group by operation. We could dive in and start to investigate this user further and say like, okay, well, I'm a little spooked. Let's just search everywhere for this particular user, and I'll just paste in this user's ARN here, and just look for all of the activity for this user and start to get a feel for what that looks like. So you can kind of see how you might dive in and start to do some investigations. Another way to do this is we'll just go back to detections. And if I pop open one of these detection alerts, I can see these details, but I can hit run query, which makes things a lot easier, which will rerun the detection rule query and will give me the same table stats that I saw before. I could turn that into a pie chart, but I could also just start to remove the aggregation function and start to just look at the raw logs associated with this particular user, open those up and start to dig in. So that's what the workflow looks like when you're in Scanner looking at detections. You can jump in and start to dive into the aggregations or into the raw logs that appear in these detections. But let's do something interesting here. So I'm going to pull up this user's name again, user identity, and we're going to do a little investigation and then create a and then we will create a detection in the UI, and then we'll jump into writing the detection as code and using the scanner CLI and how that works. So I'm going to just look for activity from this particular user. I'm just going to look over the past day because maybe this user might be doing other things that seem sketchy beyond adding malicious Lambda layers into AWS. But I'll do things. I'll look for what kinds of APIs they're using in AWS, and then what are the operations they're running. And one thing that is a bit spooky is a lot of get object requests from S3. So they might be downloading a lot of data, and which is a little scary. What we can do is we can say, okay, let's take this event source here, S3, and then the event name, get object here, get object. And then I want to see anything where the user identity type is not a service, but is actually an IAM user. That seems sketchy. And then I can start to put some stats together here. So like, for example, I'll do group by count and do like user identity dot username. And then one aspect that's really interesting is, we'll actually do this real quick just to make it a little bit easier to read, is I want to see how much data is being exfiltrated. So here's a bytes transferred out. I'll rename that to, 1 second, let's just call that bytes transferred. Or I guess bytes downloaded is good. Exfiltrated. That's even scarier. And then I can run like a stats here where I can say, here, let's sum up all the bytes exfiltrated and let's group by the user name. So these are basically like all of the users. There shouldn't be users downloading from S3. That's a little bit scary. Let's see if what's going on here. And you can see like, wow, there are a couple of users who are downloading. It looks like gigabytes, so billions of bytes. That's spooky. You can start to dig in and do things like, okay, what buckets are they coming from? And start to develop like a query that's going to reveal some activity that you want to be alerted on. You might jump into and immediately start to reach out to these users or ban them or revoke their access or something. Is it looks like, you know, the buckets that they're using are financial transactions and payment processing, sketchy. Anyways, it might be like a massive fire to go put out. But if you want to add a detection now to go and find this in the future, then let's go ahead and do that. So what we can do is we can go into detections, and the way that you do this in the UI is you can just copy paste in a detection query here. It's really easy to do like quick historical backtesting by taking your detectual query, opening up search, running it over a large time range. It can be very fast to do that. You don't have to go and like wait for it to rerun and slowly find data through other kinds of historical backtesting you might see in other tools. This is just because it's a query, you can really quickly get information back and backtest these against your own data rapidly. So I'll just pull up, I'll call this a data exfiltrated, the name, I'll just say data exfiltrated from S3 buckets by an IAM user, which is scary. And I might say, maybe that's high severity. In your case, it might be medium. Maybe this happens a lot, depends on what your policies are and how people do things. But then I can set the time range to be, to do a look back window and run every minute or something. I could make the look back window small. I could say like, maybe I only care about, let's say as total bytes exfiltrated. Maybe I only care if total bytes exfiltrated is really big, maybe like more than a gigabyte, a billion. And I could run this over and say like, let's check this every hour over the past day, or let's check this every 5 minutes, or like let's check this over 15 minutes and check and run the check every minute. You can kind of play with this however you want to. So I'll just say like anytime someone has exfiltrated more than who has exfiltrated any data, I want to receive an alert, and I'll also send it to my Torque webhook, which might like open up a Jira ticket or something for my team to dig into further. So now if we create this rule, you can see that it's been added to the list here. And this is going to start running once per minute, and it will also take a look back over the last 15 minutes due to the time range here, and give you some results right away. So we could probably just start even looking for it, even though we just barely created it, and just look for the word exfiltrated in our alerts here. Yeah. So we already have some events, and we're starting to see like we see the same sort of the like list of users who are doing sketchy stuff. Anyways, and then if you want to instead, you could visualize this a little bit differently. Doesn't have to be these bar charts. Could also be like a let's go. Let's see if I can add up. Let's delete this one, but also put whoops, I added some columns. I'm trying to get this to show as a pie chart. But I think like I can just do it this way. I'll just put it in the query here. I think my laptop is a little small. But yeah, you can visualize this in different ways and start to drill down into the data. But anyways, this is how you create a detection in the UI. They're just scanner queries. You can kind of make the queries as sophisticated as you want, or as simple as you want. That typically what we see teams do is they'll use Sigma, and we have like a beta PySigma backend plugin, which will allow you to transform Sigma rules into scanner rules. It's like a very natural fit. The Sigma rules are mostly very simple. They're just filtering to like look for a log event that matches a particular value. But you can also write your own sophisticated queries and use as complex of a query as you want to in your detection rule. Okay, Alex, I see.
Question that just came in. With backtesting, you're looking at bytes transferred by some parameters. And before you did that, did you need to decide long ago that bytes transferred are interesting enough to aggregate, or is this the first time ever that we have decided to look at bytes transferred?
Oh yeah, just the first time that we've looked at bytes transferred. It's just running a query over the data, and that field exists in all of the S3 object requests. I guess I can kind of like pull up raw logs here and take a look. So the or I guess I've renamed bytes transferred out already, but like all of these CloudTrail events for get object will have this bytes transferred out field. And I can go and I can say, yeah, I care about that, or now I care about bytes transferred in. I can go and query for anything where I guess like additional event data dot bytes transferred in is greater than some value. Or I can run sums of, I guess I don't have any bytes transferred in greater than 1,000, but I can run sums over bytes transferred in. Yeah, so I didn't need to decide that ahead of time. I can kind of just flexibly jump in and start to change or start to like add whatever fields I want to my query. And then do a back test by just running that query across historical data. So like or user identity dot arn might be useful. And I could run this over, I don't know, like a week and see what the bytes transferred in tends to be. So in this data set, this playground data set, there was no bytes transferred in. Oh, sorry, go ahead.
A follow-up to that question is, if no prior window aggregations are pre-calculated, how do you do ad hoc queries so quickly?
Oh, yes. So these ad hoc queries are just done on the index files directly. So the yeah, these particular queries. So okay, so a couple things. One is that the ad hoc queries that you can do for historical backtesting aren't running over those time ranges, but they are just running directly on the data. So yeah, if you wanted to run if you wanted to make run historical backtesting by running over like every possible 15-minute window or something like that, I guess you could do that with the API or something like that. But this I guess the historical backtesting when I'm talking about it here is more like I can explore and find events that I care about. It isn't running the like sliding window across the historical archives. So if I think like so it's not an exact historical backtest of exactly the detection rule that you've written with exactly that time range sliding along. I guess when I say historical backtesting in this case and how it's fast is you can like quickly execute different queries to find the data that you care about, and then look inside of the maybe like in the spikes and so on in the histogram to see like what is the sliding window that you really that you want to use in your detection rule. But that's a great question. So if you wanted to get exactly the historical backtest with exactly the sliding time window, you would have to create the detection rule ahead of time and see if that sliding window is triggering alerts as you desire. But I guess like one thing I can show, I guess we're close on time. I'm sorry. Is you might see something like a big spike somewhere, and then you could say like, all right, so I'm just going to drag and drill down into a particular time range and like make sure that that time window is appropriate for the detection rule that I want. Yeah, I don't know. It'd be fun to I could chat more about this offline, so I could totally understand your question. But I think I understand, which is like, yeah, it's not running exactly the same sliding window historical backtest that your detection rule is. It is, you can just use the ad hoc query system to quickly run aggregations and start to look for patterns that you would want to use in a detection rule. Hopefully that makes sense.
Another question that came in is the queries look like they're making assumptions about the structure of the logs. How do these rules work against unstructured or differently structured logs? For example, if we have data coming from Okta, AWS, and GitHub, they all have a user identity, but would we need to write the detection rule or query with knowledge of the underlying data for it to be effective?
Yes, definitely. So there are a couple of thoughts here. So one is that it is the case that Scanner is very flexible when it comes to schema, but if you don't have normalized data that's normalizing to a common schema like ECS or something like that, then your detection rules will have to be source specific. So you could say like, okay, well, I care about this thing in AWS. I care about this other field in Okta, etc. But there is a project that we're working on right now, like that's it's our focus at the moment is in our S3 import rules, adding another a step here to allow you to add ECS or Elastic Common Schema normalization for all of the common log formats that we have detection rules for. So then you can have like really easy, I guess I can even like show what the program looks like. You can define a VRL program, it's called the vector remap language, and we have templates for the common log sources, but then it will map common fields to the ECS name for those fields. So then you could write like a cross-source aggregation that looks for data exfiltration across all clouds, whether you're looking at like AWS logs or GCP logs or whatever. You could use the ECS fields for that. That's coming soon. It's not available today in Scanner. The ability to transform the logs from all these different schemas into a common schema. But that is like one of the core things that people are asking us for. That and enrichment of that common schema to add like lookups into threat intelligence feeds for IP addresses and domains, et cetera. Those are the things that we're actively working on right now. So a good question. It's not available today, but it is like exactly what we're building right now. Cool. Anything else, Alex? Any other questions?
Nothing yet.
Okay, cool. Awesome. Okay, just to we'll just jump in and quickly get into what the workflow looks like when you're writing these detections as code. The idea here is that we have a bunch of we have 12 different GitHub repositories for different log sources that have detection rules. We have 240 detection rules right now. They're really just a start, and people are very welcome to take them, fork them, write their own custom detections. So the way that these detection rules work as code is there's a particular schema that they follow with this query text, and you specify the time range and how frequently they run. And then this event sync key tells Scanner what destination what set of destinations these logs should be sent to. So like I'll actually show you what I mean there. If I go to detections and I look at my GitHub settings here, this is like our out-of-the-box detection rule set for CloudTrail, which is plugged in here. And what you see is that the last successful sync came from a particular commit here 3 hours ago. And you can see that the list of rules that it found, and all of these have all the tests are passing. And if there are failing tests, you would see a red X. And if there are any failing unit tests in those rules, then the sync will fail and it will tell you so. And it will tell you when the last successful sync was and then the last attempted sync and why it failed. So this is basically, you can configure a repository to be the source of your rules and which branch it should be reading from. And every time a new commit lands in that branch, it will run all the unit tests in your rules and then and sync it if all of the tests pass. So it gives you some assurances that as your team is developing rules, you can see who's changing what and when things break, and you can make sure that things, as people edit rules, that they're not actually causing stuff to break as things are tweaked over time. So this is that malicious Lambda layer rule that I was talking about earlier. And one of the things that you might want to do is you might say, like, I want to add an exception because this is kind of noisy and it's going off when one of our when a particular function which we're running tests on or something like that is being used. I might say something like I want to not trigger when the function name contains something like my staging CPU testing function or something like that. And then down in your unit test, you could take one of your unit tests as like as a basis and then tweak that unit test. You can copy paste logs and many logs out of here. You could copy paste a lot of logs into this inline data set. But you could say, like, let's not trigger when the function name is our staging test function or something like that. And then here you might, you can say, edit this particular detection rule to say, let's look for press parameters. And I'll just add this function name is staging CPU testing function. Let me just fix that hyphen there. 1, 2, 3. Cool. So then if I go into the scanner CLI lets you run the unit test that you have. So I can say, like, let's run a particular file. Let's see, rules, AWS CloudTrail. I think it's AWS, like malicious or Lambda. What is it called? Attached malicious Lambda layer. Let me save this. Okay, cool. Yeah, it ran all of the tests and they passed here. If I could, write a failing test to begin with or something like that, I expect the detection to go off or not, and you'll get unit tests that fail or pass, and then you can run these across all of your rules or something in your repository to go and make sure as you're developing detections together that you have a really nice workflow with your team to collaborate on them. Again, these are the detection rules are all scanner queries, which makes it very suitable for things like Sigma. If you're using Elastic or Datadog Sim or other kinds of sims that have that also use queries for their detections, or like Azure Sentinel is another. We've helped users migrate these rules. It's actually pretty straightforward. We have some scripts that we use to translate from certain queries over to Sigma, and then from Sigma to scanner queries. So most sims seem to use a query language, or many of them do, to run detections. So it can be easy to run that migration. Okay, yes, Alex, the question.
Our team is currently evaluating Scanner amongst some other tools like Panther. How do your detections differ from a tool like Panther?
Yeah, I think I covered a little bit about how our detections as code are YAML files that contain queries, and they're not Python. So I think what the Python functions allow you to do in Panther is they allow you to look at log events one at a time and maybe do some cache lookups to see, okay, what was the last thing that happened for this particular key or this particular IP address. But with the Python, it's you don't have this ability to kind of run aggregations or stats over look back windows. And so to do that in Panther, you'll jump into Snowflake and you'll write these scheduled queries, but those can be expensive. And then also running the Lambda functions continuously on data as it flows in can also be expensive to run those Python Lambda functions. So I would say a couple of differences is the query scanners detections work as queries, and you don't need to run Snowflake, which can be pricey, and you don't need to run these Lambda functions to run the detections. Scanners detections run in the state machine that runs in an ECS cluster, which is cheaper than running it in Lambdas. But anyways, you'll probably see a big reduction in cost relative to Panther if you have a lot of volume, because you don't have to also pay for Snowflake compute, and you won't have to pay for those Lambdas. But you also have in Scanner the ability to do these lookbacks, and look and do like any kind of scanner query and aggregations. So yeah, I think that those are a couple of the differences that we see. So like, yeah, the ability to go and just do really fast. So we have some teams who use both, who are using Panther and then using Scanner, but they use Scanner for the really fast search over tons of data. And they are adopting different Python rules and turning them into Scanner filter queries as well. So that is something that we've seen people do.
One last question that came in. Hopefully we have time. Is there a limit to how many rules I can run?
No, so that's another nice thing. One thing that's kind of surprising is I think Azure Sentinel limits you to like 500. But in Scanner, you can have 1,000 rules. There is a usage cost that goes up with them, but instead of dollars per gigabyte, which you might see in Azure or Datadog or something like that, it will be tens of cents per gigabyte as you increase to hundreds of detection rules. There's just more compute that's needed to run that state machine and to like create the rollup tree cache and to query that rollup tree cache. But it's just so much cheaper than doing it with other tools. So yeah, you could have 1,000 or a few thousand and still save like 5 to 10x in cost relative to the traditional log architectures you'll see with SIEMs like Azure Sentinel. But yeah, sorry, we're running low on time. Any other questions, Alex? Cool. Okay, just to finish up real quick, if you want to try the Scanner Playground and do any of the operations that I did, you're absolutely welcome to. If you go to scanner.dev/demo, you can sign up for the Playground, and we'll spin up a Playground environment for you. But thanks so much. I think we did Q&A all the way along. So, but feel free to check us out. I'm happy to answer any questions that people have and see if Scanner can be helpful with massive log sources, and also just really fun to chat technical architecture if people are using other things and want to chat about how they like to run data lakes. Would love to hear it. But thanks so much for joining, everybody, and have an awesome Thursday.